Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today, I'm going to discuss on amplification factors and application of BJT. So let us see overview of the today's session. So start with introduction and transistor application factors, and then relation among amplification factors, and then transistor as a switch. So this is one of the important application of transistor, and conclude with summary. So let us start the introduction. Before going in detail about amplification factors, we should know what are the three different configurations of transistor. Transistor can be configured in three different ways, that is common emitter configuration, common base configuration, and common collector configuration. So first, let us see. So transistor is a three-terminal device. What is transistor means? It is a transfer resistance, as the signals are transferred from low resistance to high resistance region. So these are the low resistance region. What do you mean by low resistance region? Low resistance means there is some current flowing, constant current flowing to the input side, and from this side to current flow or signal flows from low resistance region to high resistance region. High resistance region means, so ideally current is zero. So that is the beauty of transistor. So it is a three-terminal device. So we have emitter, base, and collector. It is a 2 PN junction device. So we have emitter base junction, this is one junction, and base collector base junction. And what is transistor? Why it is so called bipolar? So because the operation depends on both minority and majority charge carriers, hence it is called bipolar transistor. We have two different types of transistors, NPN transistor and PNP transistor. So the basic three configurations of BJT are common base configuration, common emitter configuration, and common collector configuration. And this is common base configuration is this one. Base is common to both input port and output port. Here common emitter configuration means emitter is common to both input port and output port. In the same way, common collector means collector terminal is common to input port and output port. So in other words, we can also say common emitter means emitter terminal is grounded. Common base means base terminal is grounded. Common collector means collector terminal is grounded. Okay. Now let us see the current amplification factors of BJT. So before applying any input signal or AC signal, so there are voltage and currents flowing to the transistor because of biasing voltage. So let us say in case of common emitter, if you consider common emitter, this is base, collector, emitter, and this is VCC, and here across base and emitter we are giving input supply, AC input signal. So before giving AC input signal, because of this biasing voltage, there are some voltages, that is base emitter voltage, and this is VCE, collector emitter voltage. So across collector we are going to measure output voltage, right? So let us see what are the consequences of applying this AC signal, that is this is the signal which is to be amplified, for example. Okay. So in a transistor, amplifier with AC input signal, the ratio of change in the output current to the change in the input current is known as current amplification factor. So this is the basic definition of current amplification factor, and we have we can define this current amplification factor in different ways depending upon the different configurations. We have three different configurations. Each configuration have we have amplification factor. So for example, in the CB configuration, the current amplification factor is defined as alpha is equals to delta IC by delta IE. So this is after applying AC input signal, because before applying AC input signal, we can write alpha is equals to DC, that is the IC by IE. So we can say this is alpha DC and this is alpha AC. The amplification factor before applying AC signal and after applying AC signal. So after applying AC signal, obviously there is a change in the collector current and emitter current. So what is first current amplification means? Current amplification factor we can also call the current gain, large signal current gain. So that is given by IC by IE, because output current by current gain means what? Output current by input current, right? So in common base configuration, if you see the common base configuration, so this is base, emitter, and this is collector. So in common base configuration, what are the input current? Input current is IE flowing out of the transistor. And what is the output current? Output current is IC flowing into the transistor. So output current by input current gives you gain. So that will be current amplification factor. This is before applying alpha is equals to IC by IE. This is before applying the AC signal. So when you apply AC signal which to be amplified, then there is a change in the collector current and emitter current. So that is represented by this alpha. Delta IC by delta IE, that is change in collector current by change in emitter current, that is change in the output current by change in the input current. Similarly, for CE configuration also, we have a current amplification factor. It is defined by beta. Beta is equals to delta IC by delta IB, because if you see the common emitter configuration, so this is VCC and this is base, collector, emitter, and this is RE and this is RB. So what is current gain here in CE configuration? So general sense, beta is equals to, we are not applying any input signal, so only we are applying DC biasing voltage VCC supply. So output, the current gain can be represented by beta, which is output current by input current. What is output current here? The output current is IC and input current is what? IB. This is output current IC and input current is IB. Now I am applying AC signal. So obviously when you apply, so this is the signal to be amplified, and after applying this AC signal, so there is a change in the collector current and base current. So that represented by this one. Change in collector current, that is output current, change in input current, that is IB. So beta, current amplification factor beta, can be represented as beta is equal to delta IC by delta IB. Similarly, for common collector configuration, if you see the common collector configuration, this is base and this is emitter and this is collector. So collector is grounded in common collector configuration. Here what is the input? Input is the IB and output is what? IE. So gamma, it is represented by with gamma. Gamma is equals to, for DC, so you can write alpha DC is equals to output current IE by input current IB. So therefore, if you apply an AC supply here, which is to be amplified signal or increasing the strength of the signal, then gamma AC, the current amplification factor given by change in output current IE by change in input current IB. So this plays a major role to calculate, to represent the performance of any BJT. Now let us see current amplification factors relationship between different current amplification factors. Particularly first, let us see the relation between alpha and beta. So alpha is for common base configuration and current amplification for in case of CE is beta, represented with beta. And we know, so before applying AC signal, we can represent the relation, we can get the relation between the three different currents, that is IB, IC and IE. So IE is combination of IB plus IC. So after applying AC signal, so it will be changes to delta IE, delta IB plus delta IC. So we know that delta IE is equals to delta IC plus delta IB. So by definition, what is delta IC? So this is from common base configuration. So common base configuration, alpha is equals to delta IC by delta IE. So that implies we can write a change in output current IC equals to alpha times change in IE. So therefore from this we can substitute this value. In place of delta IC we can replace delta IC with delta alpha times delta IE. So then I will get delta IE equals to alpha delta IE plus delta B. So whereas delta B equals to delta IE, if you common delta IE, because this one common. So if you common this delta IE, then we will get delta IB is equals to delta E into 1 minus alpha. Okay. So now dividing both sides by delta IC. So you will get delta IB by delta IC and delta IE by delta IC into 1 minus alpha. So therefore we can write 1 by beta time, because beta means what? Delta IC by delta IB. In contrast, 1 by beta means what? Reciprocal. Delta IB by delta IC. So what we have here? Delta IB by delta IC. So therefore I can write 1 by beta is equals to, and what is alpha? This is 1 by alpha, because alpha is delta IC by delta IE. Here it is reversal, so reciprocal. So we can write 1 by alpha and then into 1 minus alpha. Okay. So therefore I can write beta is equals to alpha by 1 minus alpha. So this is the basic relation. So if you rearrange this, we can also further simplify this expression as alpha is equals to beta by 1 plus beta, or 1 by alpha minus 1 by beta equals to 1. Okay. And here you can conclude that if alpha approaches unity, beta approaches infinity. So alpha always less than 1. So alpha less than 1 means its range is approximately 0.98 to 0.985, 0.985. Whereas beta ranges greater than almost up to high, it ranges from 400. Okay. So this is about the relation between alpha and beta. So let us see what is the relation between among three different amplification factors: alpha, beta and gamma. So the current in the case of CC are IB and IC, base current and collector current. So what is CC here? CC means this is base, collector, this is emitter and this is collector. Collector is grounded in CC configuration. And what is the input here? IB. And what is the output here? IE. Okay. So therefore by definition we can write gamma is equals to change in output current IE by change in input current IB. So substitute this value. Delta IB is equals to delta IE minus delta IC, because we know that IE is equals to IB plus IC, and whereas IB is equals to IE minus IC. So in place of IB I can replace. So this is delta IB equals to delta IE minus delta IC. So delta IB equals to delta IE minus delta IC. So I can replace, therefore I can get gamma is equal to delta I by delta IE minus delta IC. So after this, dividing the numerator and denominator on right hand side, that means this part. So that is gamma is equals to delta IE by delta IE minus delta IC. So if you divide with delta IE, then you will get 1 by 1 minus alpha. So this will get cancelled. So this is also gets cancelled, but we have delta IC by delta IE is alpha AC. So therefore finally you will get gamma. The amplification factor in case of common collector can be related with other parameters, amplification parameters, as gamma is equal to 1 by 1 minus alpha, and that is equals to 1 plus beta. So this is the standard relation among alpha, beta and gamma. Now let us see the application of transistor. So transistor can be utilized as amplifier. So amplifier means what? Which strengthen the weak signal. So which amplify the input signal, AC input signal. So for example, if you have an input signal like this, so 2 volts. So if you apply a amplifier, transistor amplify, then you will get a amplified signal. So depending upon the different which we have used the transistor configuration, so these signal the phase shift depends. So here let us see the how the transistor can be used as an amplifier. So let us consider common base configuration. So here this is the common base configuration. Input current is IE, output current is IC, and this is connected, RL load resistor is connected to the collector, and then we have applied VCC supply. So depending upon this voltage, your transistor ready for doing amplification. And then see here, a load resistor RL is connected in series with the collector supply voltage VCC of the common base transistor configuration as shown in figure. And now a small change in the input voltage between the emitter and base. So because we are applying input voltage, so obviously there is it will change, the input parameters will change. So a small change in the input voltage between emitter and base, say Vi, causes a large change in the emitter current, say IE. So actually we have to write change means what? Delta IE. We have to write like this. A small change in the input voltage means, let us say, delta Vi. So causes large change in the emitter current IE, that is delta IE. A fraction of this change in current is collected and passed through RL, and that is represented by alpha dash. Means, so there is a change in the emitter current and that current passes through the collector region, and that causes and passes through load resistor, and then it will cause a change in the amplification factor, and the change in the amplification factor is represented by alpha dash. Now therefore the corresponding change in the voltage across the load resistor RL due to this current is given by delta V naught. So obviously across this we consider across this collector we are going to measure output voltage. So here we are giving input signal and we are getting output signal like this, right? So the change in the output is given by delta V naught, which is approximately equal to alpha dash times RL into delta IE, because a small change in the input voltage changes the IE value, that is emitter current, input current, and which enters into the base region and then enter into the collector region, and it will flow through the load resistor RL, and correspondingly there is a change in the amplification factor that is represented by alpha dash. So therefore the current gain AV is equal to delta V naught by Vi. Here you can observe delta V naught is greater than delta Vi. The change in the V naught is greater than delta Vi. So obviously voltage gain is also increases. So that represents your transistor act as that is, it is greater than unity. Hence we can say the transistor act as a amplifier. So this is about an amplifier, how transistor act as an amplifier. You can also take another example, not only common base configuration, you can also consider common emitter configuration also. So this is your common emitter configuration. So here we are giving input signal, AC input signal, which is to be amplified. Let us say 2 volts is there, and here this is base, collector, emitter, and this is RE. However, we will have some load resistor, bypass resistor here capacitor, here also there is a capacitor C1, and across this C2, and across this you will find V0. Okay, so this is right clearly. I think this is the correct place. Across this we are applying input, and this is ground, emitter, base, collector, and across this you will have another C2, C1, and across this you will measure the output voltage. Here we are giving input signal, and here you are getting output signal which is amplified, and there is a 180 degrees phase shift between input and output. Okay, so here, because here what are the importance of these capacitors here also we have to use another capacitor, that is C3. So C1 and C2 are the capacitors used to block the DC. So C1 is connected to the base and C2 is connected to the load resistor. You can say if you apply this load resistor here RL, so therefore this capacitor C1 and C2 are used to block the DC signal, because your signal, applied signal, is AC signal, and that should be AC signal. Okay, so but we are applying VCC, some DC supply. This is the food for the transistor, and because of this VCC, your transistor ready to amplify the given input signal. Okay, so here another capacitor C3 is used. This is called bypass capacitor, and which is the mainly the capacitor C3 is used to bypass the emitter current through ground, because otherwise here RE is their emitter resistor. If this capacitor is not used, so there will be a more drop across this emitter resistor RE, so that reduces the output gain. So your signal has to amplify completely, so full-fledged amplification required. So if you are not using this capacitor here, bypass capacitor, so there will be more drop across this RE. The collector current will flow through the resistor RE, and hence there is a voltage drop across this, and hence your output or gain will be decreases. So this way also you can explain, or you can have the transistor as an amplifier. So that's all for today's session, and let us conclude what we have learned today. We have start with the transistor configuration, so CE, CB, CC, and we have discussed the transistor amplification factor, and which is, so we have DC amplification factors and AC. After applying AC, there is a change in the input parameters and output parameters. Then we have discussed what is the relation among different amplification factors, that is alpha, beta and gamma. And finally, we have discussed what is transistor amplifier, how transistor act as an amplifier by considering common base and common emitter configuration. So that's all for today's session, and hopefully the next topic will be what is the importance of biasing, how we need to bias, why we need to bias the transistors. Thank you very much.